about scientific notation. You probably have seen scientific notation before, probably in your science class, because that's what the notation is commonly used for. So copy down your target, and I'm going to talk about scientific notation while you're doing that. Here's some fun facts for you to work with. An ordinary penny contains, I can't even read that number, atoms, and the average size of the atom is 0.0000003 centimeters across. Very hard to read that way. Takes up a lot of space. It could easily be misread by all those zeros. So what is the point of scientific notation? For us to simplify this. It's a shorthand way of writing really long numbers, okay? Whether they're really large or really small. So a better way to read this would be the number of atoms in a penny is 2 times 10 to the 22nd power, and the size of each atom is 3 times 10 to the negative 8th centimeters across. Just a little bit easier. So how do we know what that means? When you read the scientific notation numbers, the sign of the exponent tells you which direction to move the decimal, okay? Very important. The sign of the exponent is going to tell you which way to go. So if you see a positive exponent, we have a really large number. This number here is really large, so we would take that decimal and we would move it to the right however many spaces we need to based off of the exponent. So if the exponent says 22, we move that decimal 22 spaces to the right. Whereas if you have a negative exponent is going to represent a very small number. That would be like this one here. You're still going to move that decimal. You're still going to move it the same amount of spots or slots as the exponent that you see, but because it's negative, we're going to move it to the left. So we would go this way, 8 spots. Okay, so there's 2 that I want you to try before you do example 1. You have 1 on your paper, and I want you to add the other one. Take a look at these numbers. Very similar. One's a positive exponent, one's a negative exponent. So if you're starting with 1 35/100ths, and it's times 10 to the 5th power, positive exponent, that's a really large number, so we're going to move it 5 places to the right. Don't leave your answer with these loops underneath it. You can write in zeros in the spots that need it. But then rewrite your answer underneath for me without the loops. You don't want to have those clumping up your answer. We want it nice and neat. And put in commas wherever is needed. So this would be 135,000. Take a look at the other number, very similar but a negative exponent. You would start with the same number, but this time, because it's negative, we would move wherever the decimal is 5 places to the left. Again, you can write in zeros, but don't leave your loops under your answer. Show me where the decimal is. We had 1, 2, 3, 4 zeros after the decimal, and then we have the 135. So this number that I wrote is in standard notation, and the number that I gave you was in scientific notation. Try these next 3, converting all of them to standard notation. Remember that if it's a negative exponent, it should be a really small number at the end. And if it's a positive exponent, you should have a really large number at the end. So try 1, 2, and 3, then press play. Okay, now that you've tried 1, 2, and 3, let's check out your work here. You should have these numbers up here on the board. 2,870,000,000 for the first one. This would be tens, hundreds, thousands, 10,000s, 100,000s, millions, so 19 millions. And then negative 509 million as well. Take a look. The negative does not matter on the number. Okay, the first number, it can be negative. That's fine. We just keep that. What matters is the negative on the exponent. That's going to tell you which way to move it. Check your work. If you got them incorrect, please make corrections. So let's focus now on changing from standard to scientific, okay? We just did scientific to standard. Now let's take it backwards. If you're starting with a number in standard form and you want to write it in scientific notation, move your decimal to either the right or the left so that the number is between 1 and 10, not including 10. So if it's 10, you're going to have to change it. You move the decimal until you have a number that's between 1 and 10, and then you figure out how many times you've moved the decimal. If you move the decimal to the left, so it was starting here, and you moved it to the left, then the times 10 is to a positive exponent. Whereas if you move it to the right, so you're starting here and you end up moving it to the right, then it's times 10 to a negative exponent. So let's try one of each of these, and then you're going to try one of each. Let's do the first one here. If I want to write this decimal in scientific notation, you have to move the decimal so that we end up with a number in between 1 and 10. Right now, this is way less than 1, okay? I have to move the decimal to the right because if I go to the left, I'm getting farther away from 1. Is this number between 1 and 10 if I put a decimal right there? Nope, not yet. Is this number between 1 and 10 if I put a decimal right there? Nope, that's 0.709. That's still smaller than 1. Move it over once more. Is that number going to be a number between 1 and 10? It will be. So you want to end up with the decimal right after the 7, which is going to be 7.09. It's going to be times 10. You need to figure out what exponent. The exponent comes from this. This was a really small number, so what kind of exponent are you expecting? A negative. And you moved to the right, so it's going to be a negative exponent. Just count the spaces. 1, 2, 3. It goes to negative 3. Let's try this one over here. You need to add this in on your notes on the top of the page next to these two. If I wanted to write this in scientific notation, this is way more than 10. Where is my decimal if you do not see it? Well, if you don't see your decimal, it's at the end of the number to the right. It's all the way over here, right? I could put a decimal in right there, and that doesn't change the value of the number. So that's where your decimal is hiding. In order to get this to be less than 10, but greater than 1, which way am I going to have to move it? It's going to have to go to the left. Is this good? Can I stop there? Nope. Is this good? Nope. Is this good? Is this less than 10? If I put a decimal right here. Less than 10, but more than 1? No, that's 117. That's still way more. Keep going until you have a number less than 10, but more than 1. It's going to be right in there. So we have 1 point. Copy down all the numbers that show up, except you don't need these zeros now. I could put them there, but they're not going to make a difference. So just copy down the numbers that show up after the decimal that are not 0. Times 10 for scientific notation, and how many spots did we move it? 1, 2, 3, 4, 5. It was to the left, so it's a positive exponent. I don't like remembering the rules this way because sometimes they get mixed up, so just think about it. This is a really big number. I need to have a big exponent. Whereas this is a really small number, it's going to have a negative exponent. All right, now you try the next two. Pause, press play whenever you're finished. Okay, so on the next two, we would have to move this one to the right. We know it's a really small number, so I already know I'm going to have 10 to the negative exponent. 1, 2, 3, 4 spots would get me to 8.11. So it's times 10 to the negative 4th. The number that you're ending with has to be between 1 and 10. Over here, 234, where is my decimal right now? My decimal is after the 4. I'm moving it to the left and making it smaller, so I know this is a large number. It's going to have a positive exponent. I moved it 1, 2 spaces, so it's a positive 2. That's going to end up with 2.34, or 2 and 34 hundredths times 10 to the second. Hopefully you got those correct. If not, correct your work. If you have any questions, please see your teacher for help. The third example then is going to be a little bit of an extension. I put the metric system over here to help you out. Let's read this. A pencil is 18.7 or 18 7/10 centimeters long. If you were to lay 10,000 pencils end to end, how many millimeters long would they be? Now, we're going to write our answer in scientific notation. You have a little bit of a trick here because I'm giving you different units, okay? You have multiple pencils in a row. You have multiple pencils in a row. So, you know, you'd be lining up one pencil end to end, then another pencil would be right next to it, and another pencil right next to it for 10,000 of them. So that's a lot. Take the length of each pencil, and we would want to multiply that by the 10,000, right? Let's think about what power of 10 is that. 10,000 is 10 to what power? Well, here's your decimal. 1, 2, 3, 4 places to get it be less than 1. So it's 10 to the 4th. Okay? But if I do that, that's going to be how long it would be in centimeters. I need to convert centimeters to decimeters. So if I want centimeters to millimeters, what am I talking about? If I want my answer in millimeters, I have it in centimeters right now. I have to do a change here. What do I do? If I have this, what did I do to get that? I have the centimeters, I need to get millimeters, so it's getting smaller, I'm getting more of them, right? It's just a change of 10. So here, we would actually just multiply by 10 to get the millimeters. That's what we're going to have to do up here. Now this isn't scientific notation, but can you simplify this for me? 18.7 times 10 to the what? 10 to the 4th times 10 would be 10 to the 5th. We're almost there, but this still isn't scientific notation. Why not? Hopefully you're noticing, wait a second, is this number between between 1 and 10? No, it's way bigger than 10. So we have to do something here. We have to do this little extra step. We need to change this one more spot. I need to move that decimal one more place to the left. If you're moving it one more place to the left, it's like you're dividing out or you're multiplying by one extra 10, right? This is dividing out a 10 here to make it 1.8. So I would need to do the opposite over here. Here's how I remember it. This number is going to get smaller, so this exponent needs to get larger to keep the number having the same value. You would end up actually having 1.87 times 10 to the 6th. If that doesn't quite make sense, let's multiply this out, because I know that's kind of a hard concept. Let's take this and multiply it out. 18.7 times 10 to the 5th. Make that standard form for me. That would end up being 18.7. We would have then 5 spots for the 0. So we would end up having this number, right? But now convert that to scientific notation. Convert that to scientific notation. Well, here's your decimal. We would have to go over 1, 2, 3, 4, 5. Oh, sorry, 6. So we end up getting back down to here anyways. Okay, make sure you always check that your answer is in scientific notation. If you end up with a number more than 10, you need to move the decimal one more place, which means you're going to need to change the exponent by one more number as well. The last one we're going to do today, then, an oil rig can host 2,400,000 pounds with its main derrick. It distributes the weight evenly between 8 wire cables. What is the weight that each wire cable can hold? Write your answer in scientific notation. So what operation would you be doing down here? You have a whole amount of weight that they can hold, and there's going to be 8 wire cables that supports that weight. So you're dividing. When you divide, what's 24 divided by 8? Well, that's 3, but then you have all these zeros, so they're going to still all be part of your answer. Okay, now you need to write it as scientific notation. Where is my decimal now? Get it to be a number between 1 and 10, and multiply it by a power of 10 in your answer. So my decimal is starting over here on the right. I'm going to go 1, 2, 3, 4, 5 to the left. So I have 3.0, or you can just write 3 if you want, times 10 to what power? Is it a positive or negative power? Well, this is a large number. It's greater than 1, so it's going to be a positive exponent. 1, 2, 3, 4, 5 spots. So it's times 10 to the 5th power. And we're talking about pounds. So let's put a label in there. So both of these answers would be good. Both would be accepted. Okay, on the bottom of your notes, you have a little bit of an extension. I want you to skip it for now, go on to your quick check, and that's going to be the extension for this lesson if you would like to do it later.